Okay, we are starting Unit 2. Okay, Unit 2 is about functions, and I put binomials in here as well just because we needed something that binomials is really short, it's only 2 lessons, so I combine this with functions. So binomial expansion is the first lesson that we're going to do. This is out of your black books, okay? Both the first 2 lessons are out of the black books, binomial expansion and binomial theorem. So let's look at what is a binomial expansion and what does it mean and how we're going to do it. Okay, so binomial, okay, you've dealt with, I hope in Algebra 1, Algebra 2, and Algebra 3, not Algebra 3, Algebra 1, Algebra 2, and then I'm thinking integrated, okay? So whether you're in Algebra 1, Algebra 2, or you're in integrated math, you should have dealt with binomials. You may have even done the binomial and binomial theorem. So when we have something that looks like this, something plus something to a power, it's called a binomial, okay? And n is the power of the binomial. Okay, so if we want to do binomial expansions when the power is 2, okay, binomials follow all these great patterns, all right? They look like that, a squared plus 2ab plus b squared. So whatever a and b is, whether, I mean, they could be, a could be 2x to the third, and b could be yx to the fifth, and we can plug them in there to those places and simplify them so they come up to this. So the binomial expansion is beautiful because it gives us the really nice patterns. So we just finished sequences in series, sequences in series. I can't talk today, I'm sorry. And these are nice patterns. They follow nice patterns. So it gives you these 2 in particular. Right? It expects you to know those. All right. So as far as memorizing those, I expect you to know the first one. The second one I probably would give you on a test or a quiz. But then the next thing to be aware of, and I might not because you can always use Pascal's triangle. So I'm going to assume we have seen Pascal's triangle before, and that, but the binomial expansion follows the rules of Pascal's triangle, which is really nice. I want you to look really quick here. So when we have a 0 power, everything's 1. When it's to the first power, it's going to be basically the coefficient, that's the coefficient, the number that goes in front of it, all right, is 1 and 1. So if this right here were 1, it's just the a plus b. Okay, that's the coefficients that are in front of it. When we have it to the second power, the coefficient of the first term is 1, the coefficient of the second term is 2, and the coefficient of the third term is 1. Now, how do we find these numbers? 1, 1, and 1. Those are just given. 1 plus 1 gives me 2. So our ends are always 1. And then we're adding to get the middle term. Okay? So the third row, coefficient of the first one is 1, second one is 3, third one is 3, and the fourth one is 1. Okay, it follows the Pascal's triangle. So it's really nice to have those. We're going to look at another rule here in just a minute so that we can figure out, well, what do my powers look like? All right? So, oh, nope, we're not. We're going to use these rules. Sorry. Maybe the next example. So example 1. It says, use the binomial expansion of a plus b to the third to expand and simplify p plus q to the third. So I'm going to follow the same rule. I have p and q instead of a and b, which is really easy. I probably should have picked a harder problem for our example. But this becomes p to the third plus 3p squared q. Okay, all I'm doing is following the pattern for the third power. Plus 3p q squared plus q to the third. Now, your example isn't quite as nice, all right? It has 2x to the third, and I gave you the rules there still. But I want 2x and a 3. I want you to realize that, like, for example, for 2x, or my 2x is my a. So when I have this, I need to write 2x to the third, and I need to simplify it. So it's 2 to the third, x to the third, 2 to the third is 8, x to the third. So as you're plugging them in, make sure that you're using parentheses and you're simplifying as you go. All right? Your solution will be on the next one. Okay, there's your solution. Okay, you realize they simplified everything. Okay, example 2. All right, so this one wants us to use Pascal's triangle and to follow the pattern. I thought for sure I had put this somewhere. So I will explain this through this example. So Pascal's triangle, this has a 5. So we need to go to the 5th row. So we have row 0, row 1, row 2, row 3. We already knew this one, right? Row 4 is 1, 4, 6, 4, 1. I'm just adding. 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. And then row 5 is 1, 5, 10, 10, 5, 1. So we always start with the ones and go with them. All right, so how does this follow a pattern? So first of all, we know our coefficients. So we have x and 2. So the first one is going to be the first one to the 5th power. That's just the way it starts, okay? To whatever power that is. So this is going to be x to the 5th, all right? And my last one, likewise, is going to be the last term to the 5th power, 2 to the 5th. I'll look at everything in the middle. So first of all, we know that my next coefficient is going to be 5. It's going to be 5 times, okay? Now I'm going to work my way down, okay, in order by exponents on my x's. And my 2's, my exponents are going to increase. So this is going to be x to the 4, and then 2 to the first, which is just 2, but I wanted you to have it in small type together. All right, then my second one is has a coefficient of 10, okay, x to the 3rd, so I'm going down, right, times 2 squared. Right. My next one, I'm going to run out of space here, so this is going to have to come on the very end. It is plus signs all one move, so you know that. It's going to be plus 10. Now I'm going down with my x's, x squared, up with my next one, 2 to the 3rd. Then I have plus 5 times x to the 1st times 2x, or 2 to the 4th, and then plus 2 to the 5th. Okay, so I hope that's clear on how we're going to follow. We're following patterns. Okay, so all we're doing is following patterns. Now we're going to simplify. This is x to the 5th. 5 times 2 is 10. That's 10x to the 4th. Okay. 2 squared is 4. So I'm going to have 40 x to the 3rd. Okay, 2 to the 3rd is 8. So plus 80 x squared. Okay, 2 to the 4th is 16. Plus 80 x squared. Plus 2 to the 5th, which is 2. Alright? So that's all we're doing for these examples. Okay, let's do a practice problem. So this one, we've already found the 5th row of Pascal's triangle, so you just need to do that, and then the binomial expansion. Notice it's a little bit harder. I did that on purpose, okay? You can do it with a fraction. I promise you can. Good luck with that. Here's your solution. You're not going to see it if this thing's in the way. Okay, there's your solution. I'm going to move it over here so you can pause and check out your solution. Okay. Example 2. Actually, I think this one only had 2 examples. I will see you tomorrow. Let me double check and make sure that I didn't actually have another example that I forgot about. Nope. I'll see you tomorrow.